So I'm very, very proud to have Dr. Gavin Wood up on stage to deliver the latest information about what's happening in Polkadot.
Thanks, Mark. I come here not as CEO of Parity anymore, but as one of the 3 chief architects of Polkadot and the fellowship. The talk isn't really an update on the latest stuff across Polkadot. It's more of a reflection of some of the long-term trends in the world, and particularly the ones that are relevant for Polkadot and its architecture. The world is changing. The last 5 years, many things have changed. We've seen the effective outlawing of Web3 technologies, and we've seen increasing eyes on regulation of the industry, with some voices calling for a level of regulation that I think would effectively outlaw what I put forward as Web3. Taking China and Russia aside, if we look at the long-term trends of what's going on in the Western world, we do see an increased weaponization of finance and identity, for that matter. If you look towards countries like Sweden, I think you see probably a taste of the future, where cash is all but unused and banks are used for almost all payments. Passports are increasingly needed throughout life in society, especially for any significant economic transaction. And the overall trend throughout the West is against individual freedom, particularly economic freedom. And it's aimed towards a greater level of social control, just a little bit less obvious, perhaps, than it was 70 years ago. I think we're going to see some very instructive things happening over the next 5 years. I think over this time horizon, we're going to see quite how unreasonable the established authorities will be towards this technology. I mean, let's be clear, this technology opens up more possibilities, opens up new possibilities. This is why it's an interesting technology. This is why it's a disruptive technology, right? It opens up possibilities for things that were not possible before. And opening up new possibilities is scary for many people, because they quite like the world as it is, thank you very much. But you can look towards the US, maybe some of the sort of, commodities and securities regulators there. You can also look towards the EU. Some of the lawmakers, some of the regulators that are quite keen on exerting a level of social control that you wouldn't necessarily get in the US. But in both camps, we see ideas against the continued development and deployment of this technology. They're what I would call quite anti-freedom, at least on the individual basis. But they are, I would say, gaining some traction. And over the next 5 years, we'll see quite how much traction they have. All of this tells me to be prepared. The world is changing. And for autonomous rule-based systems like Polkadot, Web3 systems, if you like. And when I say Web3, I really mean the thing that I was talking about like 9 years ago, not NFTs or like crypto kitties or anything. In order to survive in this environment, they need to be resilient. And when I say resilience, we need to understand what the word resilience means in this context. We also have to understand what tools we have to deliver resilience and the areas in which the resilience must be delivered. But I'm going to sort of boil it down to 3 things: security, ubiquity, and this beneficiality, the idea of bringing benefit to many people. For a system to be resilient, a system like Polkadot to be resilient, it has to have all 3. And in terms of tooling, what do we have to deliver resilience? We have cryptography, and there's a few avenues of cryptography that we can use. Cryptography that delivers authenticity, the ability to authenticate, so things like hashing, things like signing, digital signatures. We have a crypto privacy avenue of crypto, so things like encryption. We have game theory, economics, branch of economics, to help us understand how to create incentives that deliver particular emergent effects. And we have decentralization, which is often sort of used by game theory as a means of giving guarantees through knowing that there's lots of individuals with divergent interests taking their part in the game. So what areas are we looking into? Consensus, quality of service. Quality of service is basically, I want to do something with this system. What stops the system from being subject to a denial of service? There should be a degree of service that it gives to all individuals. Governance, like how do we change the system over time? Presumably version 1 is not the only version of the system. We want to actually change and adapt to the changing environment. Transacting and messaging. So basically, messaging is a more generalized concept of transacting. Transacting is like a message. Transaction is literally just a message, a string of bytes that you send to the network with the idea that it will eventually make its way into a block and have some sort of effect that you were intending. Well, messaging is just the general concept of sending a message to somewhere on the network. Maybe it's a person, maybe it's a node. Development and adoption. So the development, like governance is sort of making a decision about how the system will change over time. It's authorizing the changes. Development is actually making sure that you have some book of changes that you can get done. And adoption, which is essentially, letting it be known that these services are available and maybe in some sense informing individuals that may not otherwise know that they can use it if they wish. Perhaps persuasively informing. Identity and personhood, which is an attribute that individuals have, that people have, that can be useful when used within these systems. So let's look at the Ubiquity. One of the ways that Polkadot is really pushing on the Ubiquity front is this rather amazing piece of software called SmallDot. SmallDot is a piece of software that sits anywhere where WebAssembly can sit. So it can sit on a mobile phone, it can sit in a web browser window, and it connects directly to the Polkadot network. Indeed, it connects directly to any parachain network built with Substrate. It can synchronize in seconds with the network and provide all of the transacting and querying services that you would need in order to build a decentralized, unstoppable application. Here is an example. This is a very simple application by SmallDot. I just reloaded the page there. It's now going to the Polkadot network. It's fetching the headers. There we go. It's done it with Kusama. It's done it with West End. It's now syncing a parachain on West End. Takes a few seconds to sync, and there you go. So this web page contains all of the code needed to actually connect to nodes on the network. We're not going through an RPC server. So when you use a typical Ethereum application, you will tend to go through the MetaMask thing, which internally will go through an elastically scaled server farm that just runs a lot of Ethereum nodes and serves out requests. This is owned by a single company, has a single controller, and if for some reason the US jurisdiction knocks on the door and says, right, you can't use this, we don't want this DApp to be available anymore, we don't want anyone using this account anymore, whatever else, they will basically have to turn it off or shut down. This is not susceptible to that level of attack. So it's not susceptible to your typical, sovereign actor attack. It's not susceptible to errant sysadmin attack. It's not susceptible to the same kind of software bug attack. It's not centralized. It's good for all the reasons that we're here in the first place, building a decentralized network. And the nice thing is, it sits right in the browser, in the web page. So you can add this to any website that you want, and it will just suddenly be able to access Polkadot, the Polkadot network, without going through a centralized intermediary. This is necessary. This delivers the level of ubiquity that is required part of building resilience into the network. It's not all we need, but it is nonetheless a requirement. Without it, we cannot deliver ubiquity and we cannot deliver resilience. So this is kind of part of scalability. We've got a few bits here. One of the things that I'll talk about a little bit towards the end of the talk is the Hermit Relay, which is basically moving all of the stuff that happens at the moment on the Polkadot relay chain, which is really just meant to be this sort of big security apparatus for each of the parachains, moving all of this stuff like staking, like governance, down into the parachains, which makes the relay chain basically something that is never directly transacted with. The relay chain just basically becomes this big coordinating, securing chain. The other elements, there are quite a number of other elements on the way to delivering scalability, making it beneficial to many, but that's not the point of this talk. Now, governance. So this idea of decentralizing the decision-making apparatus, the sort of crucial big decision-making apparatus. This is something that is actually changing in Polkadot. The original form of governance that Polkadot used and that many of the parachains on Polkadot and Kusama uses is being slowly deprecated and removed in favor of a new form of governance that allows for fewer bottlenecks in terms of decision-making. It allows for a lot more decisions to be made at the same time, and it allows for decisions of differing levels of security to have differing requirements in terms of turnout, in terms of time period for decision-making, and in terms of the actual required approval level. In addition to this government thing, there is also a fellowship concept, and it basically builds a on-chain body to allow the chain, we must think of this in terms of the chain, not in terms of companies or people, but the chain, to safeguard the expertise, which allows it to continue its maintenance long-term and improve itself. So it's now the chain is trying to look after itself. This is like kind of new chain-centric way of viewing the world. So OpenGov, this is a subsquare. It's a quite nice interface that's been developed for OpenGov, supports this second version of governance. In this case, got a couple of referenda. If you look at the side, there are many different tracks. Each track has its own, what we call origin, which is basically permission level or privilege level. Some privilege levels are lower than others. If they're lower, it means it's easier to get the referendum to pass faster. So, for example, the root, this is the most difficult track to get passed, and there are some spending origins a bit further down that are much easier to get past. Fellowship actually quite cunningly uses the same code, but instead of it being everyone that votes, it's just this very small group of people that are selected and maintain their position within the fellowship based upon this kind of meritocracy, this peer-based meritocracy. Next thing, transacting and messaging. There are two ways that we're building resilience into this. One of them is through introducing an increased level of privacy for transacting and messaging, and another one is actually by introducing generalized messaging within the Polkadot core protocol. So the internode mixnet is essentially a way that the nodes can talk to each other, submit transactions between each other, and share messages between each other without knowing precisely where the message came from, where the transaction came from. It uses some technology of which the spiritual forebear is Tor. Called onion routing. But basically, it allows a degree of privacy. It means that when my computer submits a transaction to the network, the transaction does arrive on the network, but nobody on the network knows that it was my computer that submitted the transaction in the first place. We are now moving into a position where we can give certain proper guarantees about transactional privacy. The small certifications hub, or the messaging layer, is similar to when one submits a transaction, except the messages are not necessarily transactions, they can be any kind of statement. And this is a facility that dApps can use, that the chain itself can use. Indeed, chains can send messages themselves if they want. So you might have, for example, an account sending a message. You can also have like a multi-sig wallet sending a message. They kind of work in the same way. This allows for things like off-chain messaging to happen without having to go through a centralized intermediary that actually passes the messages along between the actors. There are all sorts of use cases where you don't necessarily want to go on-chain just in order to send a message. You want to do some kind of coordination between the actors off-chain, because going on-chain is expensive. You have to mutate anything that you have to like transact and mutate information on the chain becomes expensive. So rather than doing that, you might want to coordinate between the actors off-chain, and only when you've come to some sort of final agreement that you both like, actually move it on-chain. An example would be something like decentralized eBay, where you might want to put the article for sale, you might want to advertise it, but you don't necessarily want to put it on the chain, the advert, because there's no actual need. No transaction is actually happening putting the advert on chain. You merely want other people who might eventually want to buy it to be aware that it is for sale. Once they're aware it is for sale, they might then make an offer on chain for the transaction that you can then say, yes, I agree, and fix a price or whatever else. But the point of advertising the chain shouldn't really need to be involved. But the problem is that infrastructure doesn't exist. The chain has to be involved with the way blockchains work at the moment. Well, this provides a means of not necessarily having the chain involved at that point, before there is really a deal to be done. Okay, next point, development and adoption. So this is where a couple of things that I was working on a month or two back come in. Polkadot salary and the core membership logic. This is taking further steps really to build resilience into Polkadot, particularly by making Polkadot less reliant upon centralized organizations that live in the sort of real world. Web3 Foundation and Parity would be two of them. The Polkadot salary essentially allows people to take a salary, I say in inverted quotes because there's no like legal arrangement behind it, it's literally just the chain making a series of payments for some time period to individuals that are contributing to Polkadot's knowledge base, that are contributing to Polkadot's continued existence and development. The core membership logic allows for this meritocratic organization to exist within Polkadot. The moment there's one fellowship on Polkadot, the core developers fellowship, which really is about providing a body that encompasses and incentivizes expertise relating to the core protocol of Polkadot. But in principle, there can be many such bodies relating to all sorts of things to do with Polkadot. There could be a body for the Polkadot ambassadors. In fact, I think that's actually being launched quite soon. There can be a body for ecosystem technical knowledge. There can be a body for legal knowledge, like kind of paralegal knowledge. One can imagine all sorts of meritocratic bodies that Polkadot can basically incentivize to exist within the Polkadot ecosystem. And this logic can be reused for that. That's the resilience part of the talk. I also want to talk a little bit about some of the things that have been happening recently on the technical side, which is the side that I am focused on. So XCM version 3 has launched. It's on Kusama now. And modulo a few teething issues, it seems to be working okay. This paves the way to XCM version 4, a little bit more on that later. There is some of the things that we needed to do to make XCM work swimmingly well for parachains included two-dimensional weights, which is basically allowing for the measurement of not just execution time for any given operation, but also how much within this parachain proof of validity, basically the bandwidth requirements for any given operation. At the moment, because the bandwidth requirements are not important for the relay chain, weights were only one-dimensional, which means you only measured how expensive an operation was in terms of this execution time. Well, now these operations are measured in both execution time and bandwidth requirements, and rolling this out was, let's just say, a non-trivial job. The message queue, which is the thing that XCM messages get queued up in and eventually executed, also needed to be aware of this two-dimensional weights, and again, that has taken some time to retrofit. Thankfully, that work is very nearly done, and we'll be able to move on to more interesting things, at least things that make a bigger splash. One of the things that we've also, well, that I personally have been working on is the holding and freezing mechanisms. Again, this is like a little bit of cleanup from 2 or 3 years ago. You might be familiar with the idea that in Polkadot, the relay chain, you can stake. When you stake, your funds get kind of locked up, but you can still vote with them. So you can still like go into governance and say, right, I'm going to use my funds to vote with. Really what we wanted to do is make this substantially more generalized and allow funds to be kind of used for more things than just these two. There are also a number of other sort of problems that were introduced that were not sort of known at the time. Things like if you have locked your funds up for staking, it's not immediately obvious that they are locked for staking. There might be other reasons why you've locked up your funds as well. You might have locked them up for, I don't know, putting a name down in the name registrar. I don't know. There's I don't know, maybe 10, 12, 15 different reasons why your funds might be locked. It's very useful to know what those reasons are. And it's not so easy for user interfaces to actually display that information at present. Well, this changes that, and it makes certain that this information can be displayed in a very nice, user-friendly way. Two of the new things that are going to be worked on for those people who are actually doing technical stuff: tasks, which are a new abstraction within the frame system. Tasks are basically chunks of work that need to be done, but don't need to be done right now immediately, but it's good to get them done at some point in the future. It allows you to actually describe these bits of work, describe how to do them, and know that over time they will be done. Pretty general stuff, and you might think it sounds like kind of trivial, but having the abstraction mechanism there massively simplifies a huge amount of code. Because a lot of the time in a blockchain, when you're writing your decentralized application, when someone does a transaction, you kind of need to record that the transaction was done and do some bits that are quite cheap to do, but kind of make sure that nothing bad happens knowing that the transaction has gone in. There are usually other bits as well that you need to do that are much, much more expensive, but don't actually need to happen right there and then. They can happen at some point later. This is exactly what tasks are for. An example would be if you want to upgrade some part of the system. Well, you need to upgrade every account, but you don't actually need to upgrade the account like to whatever the new format of data structure or whatever is until the account's used, and the account might not get used some time. But the only at the moment to be safe is to actually go through every account at the point of upgrade and change all of this information. And much better is basically just to record that the upgrade kind of happened, but not the accounts are not yet upgraded, and then kind of work off the workload one by one as you get around to it. So basically you're going to have a task for every account to kind of a to-do list, upgrade this account. That can be done at some point in the future, or if you really need to use the account at some particular point, make sure it's done immediately before, sort of just in time as part of the code. Right, finally, XCM version 4. So, as I said, one of the main points of this release is for the Hermit relay. So the Hermit relay is the idea of a relay chain that you don't transact with. The moment you transact with the Polkadot relay chain, for many different reasons, you might be registering a name, you might be putting yourself down as a validator, you might be nominating a validator, you might be staking, putting some bond in place, you might be voting, you might be putting a proposal for a vote, you might be transferring some tokens. Lots and lots of reasons why you would be transacting with a relay chain. Well, what we want to do ultimately is move all of those reasons out onto parachains, so that the relay chain does the only thing it's meant to do, which is secure parachains. This provides substantially more bandwidth for actually doing its job, securing parachains. Some of the other things we're building into XCM version 4, DEX support with query exchange, basically querying an exchange rate. before you actually do the exchange. NFT support, or better NFT support, with synchronized metadata, so essentially allowing metadata for NFTs to be synchronized, providing an abstraction mechanism to allow them to be, the metadata to be synchronized across chains. Again, this probably won't mean much to anyone who isn't quite deep into XCM, but agents, so basically allowing a location on the sort of universe, the consensus universe, to set a particular account that acts as its agent on whatever chain. This means that anything that can, any functionality of the chain that deals with accounts can now deal with XCM. So it basically makes XCM much more useful for use cases that don't actually are not designed to work with XCM specifically. Temporary accounts, this achieves a similar thing, but it allows XCM programs to have a temporary account, like a real legitimate account ID, can hold tokens and stake and do whatever else, but it allows you to create a temporary account while this specific message executes. Finally, origin stacks, same kind of thing, opening up more XCM use cases. In this case, it allows you to mutate the origin, but then, which is basically the location that the message is coming from, but then at the end of the message actually revert it back to what it was before, maybe do some cleanup with the same privilege level that actually started the message off.